Okay, 7.3 is called integration by parts. This is one section in the first 7 chapters, I guess in the first 8 chapters, that we didn't learn. That wasn't on the A-B test, it's on the BC test. There were two, integration by parts and the length of a curve were the only two in 1 through 8. So we have to go back and relearn these two sections. Um, there's a very, very long, difficult way of solving integration by parts, and there's a quicker way. The quicker way is called tabular integration. This is the way I'm going to teach you. If you remember, we watched the movie last year called Stand and Deliver, and he did this method on the board. He called it the tic-tac-toe method. Okay, this is when you have to do the product rule, when you need to integrate the product rule. I'm just going to bring back the product rule. The product rule was when you have two things underneath the radical and you can't simplify it. For example, if you saw x parentheses x plus 2 dx, you do not need to use the product rule because I can simplify this to x squared plus 2x dx, and then I can integrate the x squared to x cubed over 3 plus x squared plus c, I guess it would be, there's no limits. You do not need to use the product rule if you can simplify it first. And in this case, you do not need to use the product rule. The rest of these today, you need to use it. So I'm going to give you an example. I'm going to give you 1, 2, 3, 4 examples using the tic-tac-toe method or tabular integration. So, number 1, you're going to integrate x, we're going to integrate x cosine of x dx. No limits. I think, let me see here if there's any limits. There are no limits right now. I can do one at the end that has limits, but most of these you will not have limits. You're just gonna integrate. So, do you notice that there's an x and a cosine of x? There's two different functions. If there's two different functions inside the radical, you need to use the tabular integration. So, you're going to make a little table. You're going to find the derivative of the first one, and you're going to integrate the second one. The derivative, well, I'm going to start out with x, and I'm going to copy down cosine of x. I'm going to take the derivative of x, and the derivative of x is 1, and the derivative of 1 is 0. You keep going until you can't go any farther, and I can't go any farther. The derivative of cosine is a negative sine of x. Sorry, I'm not taking the derivative, I'm integrating on this side. What's the antiderivative of cosine? Sine of x. What's the antiderivative of sine of x? Negative cosine of x. What you do then is you're going to connect these two with each other, and the first one goes positive, then you're going to connect these two with each other, and the next one's negative, and there's nothing else to connect. So, the final answer is you're going to multiply those two together, which is x sine of x. You're going to put those two together, and since you have a negative and a negative, it's a positive cosine of x with your plus c at the end. Final answer. Okay, let's do the next one. Number 2, y equals x e to the negative x. Let's start one more. Let's do one more without limits. Let's do y equals x squared ex. And we're going to integrate this. Dx. Derivative, integration, x squared ex. The derivative of x squared is 2x. The derivative of 2x is 2. The derivative of 2 is 0. The integration, e to the x. It's e to the x. It's e to the x. These two go together and it makes positive. These two go together and it makes negative. And these two go together to make positive. Final answer, x squared e to the x minus 2x e to the x plus 2e to the x plus c. Okay, one more, except we're going to solve an initial value problem. And then I'll start doing limits. dy dx equals 2x square root of x plus 2. And the initial spot is at y equals a negative 1 comma 0. We're supposed to come up with the initial value, which means we need to find the y. So we're going to integrate. We're going to integrate 2x square root of x plus 2 dx. We're going to use what we were doing. I'm going to put 2x down here and x plus 2 to the 1/2 power here. These problems are slowly getting harder. Draw some lines. The derivative of 2x is 2. The derivative of 2 is 0. The antiderivative of x plus 2 is add 1 to 1/2, which gives you 3/2, but when you divide, it's really multiplied. I got to do it again. When you add 1 to 3/2, you get x plus 2 to the 5/2. But you're really multiplying the 2/3 times 2/5, which makes 4/15. So, as you can see, these problems are getting harder and longer. I'm going to put these two together, positive. I'm going to put these together to make them negative. So, it's going to be 2x times 2/3 parentheses x plus 2 to the 3/2 minus 2 times 4/15 is 8/15 x plus 2 to the 5/2 plus c equals y. We put a plus c at the end because they gave us 2 points. The 2 points stand for x and y. In place of y, I'm going to put a 0 and leave my c. In place of all the x's, I'm going to put a negative 1. So when I put a negative 1 right there, negative 1 plus 2 is 1. 1 raised to any power is still going to stay 1. I plugged a negative 1 in there, so all I have left is this. So 2 times a negative 1 is a negative 2. A negative 2 times 2/3 ends up being a negative 4/3. That's for all of this. Minus, I'm going to plug another negative 1 in here. Negative 1 plus 2 is 1. 1 raised to any power is 1. So it's going to be left with a negative 8/15 plus c equals 0. I'm going to change this to 8/15. So a negative 8/15. Okay. What did I do? I know what I did wrong. Let me start again. I'm sorry. One more time here. This was a negative 4/3. I'm going to show my work down here. Multiply. Now it's a negative 20/15 minus a negative 8/15 plus c equals 0, which makes a negative 28/15 plus c equals 0. So c must equal 28/15. All I'm going to do is, to make it easier, I'm going to bubble this in. This is my final answer. Instead of rewriting it, and I'm going to erase the c, and in place of the c, I'm going to make it easier and put 28/15 here. Final answer. Okay, now I'm going to start adding points in, and you're going to see how drastically harder they get. So here's my next one. Y equals x e to the negative x from 0 to 3. So I'm going to integrate from 0 to 3 x e to the negative x dx. I know I need to use tabular integration because I've got two different functions. Derivative here, integration here. I start with x, I start with e to the negative x. When I integrate x, I get 1. Sorry, derivative, not integration. When I find the derivative of 1, I get 0. When I integrate e to the negative x, okay, how do we integrate e to the negative x? I'm just going to come over here and show you. I'm going to let u equal a negative x. I'm going to let du dx equal a negative 1. So a negative du needs to equal dx. So if I integrate this, I'm going to use e. I'm going to replace my u with a negative x, but I'm going to replace my dx with a negative du, so there's going to be a negative sign out in front. I'm going to do the same thing with this one, but when you do it, it's going to end up being e to the negative x. And when you do all this again, you're going to find out that the negative changes to a positive. And I'm done. And now I'm going to do my tic-tac-toe method. These two go together with the plus. These two go together with the minus. So, I'm going to write it down here. It's going to be a negative x, e to the negative x. This is going to be a negative e to the negative x, and I'm integrating this from 0 to 3. And all you're going to do is you're going to plug 3 in for all the x's. So it looks like a negative 3e to the negative 3 minus e to the negative 3 minus, in place of all the x's, you're going to put 0. When you put 0 in there, though, it cancels out. So the negative 0 times e to the 0. And anything raised to the 0 power is 1, so you're just going to be left with a negative 1 right there. And I kind of fast forward this. When you do all the math, you're going to get 8 for your final answer. Okay, last problem. This took a whole page. As you can see, BC is harder. I'm going to do one last problem for you. We're going to integrate from 0 to pi over 2, x cubed cosine of 2x dx. These problems are getting harder and harder. This is the d, this is the integration, x cubed goes here, cosine of 2x goes here. The derivative of x cubed is 3x squared, the derivative of 3x squared is 6x, the derivative of 6x is 6, and the derivative of 6 is 0. You can tell that this is getting longer and longer. I got to come over here in antiderivative, so I need to let u equal 2x, du dx equals 2, so du divided by 2 equals dx. I'm going to have a a 1/2 out in front. And I showed you how I got the 1/2. And I'm just going to leave it as cosine of u then on the inside, which ends up being 2x. I'm going to do the same thing. I got to use u again as equal to x. But when I do this, now I'm going to end up having a 1/4 out in front because I have to divide by half. But the antiderivative of, sorry, I don't know why I keep making mistakes, but I do. The antiderivative, okay, everyone sees how I got the 1/2. Antiderivative of cosine is sine, not of 2x. Sorry. Now, the antiderivative of sine is negative cosine. Let me write the 2x. And you do the 1/2 again, and that's how we got 1/8. And the antiderivative of cosine is positive sine, but you still got to derive that negative. Again, 1/2 is 1/16. And it's going to end up being a positive 1/16 because the antiderivative of sine is a negative cosine. So you've got to be really careful with the negatives and the positives. You got to do your tic-tac-toe method. This is very hard. This is positive. This is negative. This is positive. This is negative. So, I know this is a very long problem, but this is what it's going to look like. 1/2 x cubed sine of 2x by putting the first lines together, plus 3/4 x squared cosine 2x minus 3/4 x squared cosine 2x. I'm losing it. Minus 3/4 x sine of 2x minus 3/8 cosine 2x from 0 to pi over 2. Okay, sorry. I'm going to put these two together because they both have sine of 2x. And I'm going to put these two together because they're both cosine of 2x. So this is what it would look like. I'm going to take a sine of 2x out of both of these. And what do you have left when you take a sine of 2x out of both of these? You're going to have 1/2 x cubed minus 3/4 of an x. Plus, I'm going to take a cosine of 2x out of both of these. And I'm going to have 3/4 x squared minus 3/8 from 0 to pi over 2. Okay, so basically you need to put pi over 2 in all of these. If you put pi over 2 in all of these, you're going to double this to make it 180. So we're looking at -1 and 0. If you put 0 in both of these, we're going to be looking at still 0. So we're going to be looking at these two spots when we plug pi over 2 and 0 in. When you plug pi over 2 or substitute in there, you get 180. The sine of 180 is 0. So this whole thing is going to disappear when you plug pi over 2 in there. The only thing you're going to have left is this part. And the cosine of 180 degrees is a -1. So this right here ends up being a -1. But then you have this part right here, and you have to plug 3/4. In place of x squared, I need to put pi over 2 raised to the second minus 3/8. Same thing with the next one. I'm going to plug 0 in, and when you plug 0 in, the sine of 0 is 0. So this whole part again cancels out, and you're going to be left with only this part for the 0. And when you do that, you're going to have a negative. The cosine of 0 is 1, so that's gone. You could put the 1 out there if you want to. When you plug 0 into here, you get 0, so the only thing you have left is a positive. It's going to be 3/8 left. Then, when you simplify this, you get give me 2 seconds here. Okay, let's finish this. For some reason, this needs to be, I got mixed up, but this is supposed to be 0 plus 3/4 pi squared minus 3/8 minus, well, that is a 1 there, but there needs to be a 0 there. I made plus 3/8. I can't see them putting this hard of a problem, but 3 pi squared over 16 minus 6/8, which ends up being in simplified form 3 pi squared over 16 minus 3/4. I'm going to give you the odd problems in this section. I think I might have you try one of these harder ones. But don't lose sleep over these harder ones. I mean, this is where you would have to get your 5 to finish this problem, because this would take a long time on the AP test.